Yeah, so obligatory about me. So McConnell, senior at Whitespace. It's a new startup in Belfast. Primarily, we're in the fintech sector. We sort of touch on basically anything that is of interest to us. I am a wearer of many hats. I do everything from sort of product management, front-end React stuff, through to database architecture and ops. My ops side has really just been managing, existing platforms, Google App Engine and such. But one of our future projects, which is coming up, is to actually build out the first official cyber or cryptocurrency exchange. So I figured I'll probably need to brush up on my ops side. I've played about with EC2, played about with auto scaling groups, but I've never really done anything big. But obviously for something like a stock exchange, there's a lot of red tape, there's a lot of things we have to abide by, so we can't really allow someone else to manage that for us. We have to have a fully managed in-house infrastructure. Obviously, I have no idea where to begin. So naturally, I went to someone who did know about sort of this infrastructure, an SRE, and basically asked, where should I start looking? They naturally sort of sided towards the analytics side of it, sort of tracking metrics, tracking trends, tracking things that are already happening on a platform, but I haven't built my platform yet, so where should I start? So I was then introduced to this concept called chaos theory and chaos engineering. Have any of you heard of chaos engineering? Yeah, quite a few. So Netflix created this principles of chaos. So it's as official definition as you can get. So chaos engineering is the discipline of experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. So this is the thing we've all been hearing about, the testing in production, the big scary. So what this basically boils down to in layman's terms is, if I have a system and I think it is capable of, picking up a dropped instance, if I start poking that, will it actually pick up that dropped instance? Just before I get onto that, one thing, so what chaos engineering differentiates between that and testing. Testing, we know what the input and output is going to be. We control the variables going into a system, and we know pretty much what's going to come out. Chaos theory is more about, I have these 100 coins. If I throw them up in the air, I don't really care what happens up in the air, but my assumption is 50 of those coins are going to be heads, 50 of them are going to be tails. If that's not the case, then I have something to work with and have something to go forward with. Ultimately, you're never going to test for every single scenario. Your users are going to use your system in ways you cannot possibly fathom. You think, I have a simple form, it does X. Of course, someone's going to click on that form and hit submit. No, they're not. It just doesn't work like that. And it's not even just users. If you have a large platform of, say, even 20 services that all interconnect, Frank wakes up one day, who's the lead developer on service A, and decides, do you know what, that Python service we've built, it's going to be Node now. You don't know Node. You don't really care about Node. Ultimately, what you're caring about is, if I still put in A to that instance, do I still get B out? At the start, I've mentioned this sort of site reliability engineer. At the start, you're really more focused on site unreliability engineering. You want to make your system strong, but you want to focus on how best can I, poke the bear. How quickly can I knock this thing over, and what practices should I be doing? So, as I say, testing, we're ultimately confirming what we already know, whereas the chaos engineering is experimenting. It's seeing what happens whenever I do this weird thing and the output we get from it. So, as mentioned, Netflix are sort of the pioneers on this sort of side. Obviously, they have a lot of services. They need to make sure they're always available. If someone can't get their RuPaul's episode 24, they're going to complain. So Netflix released this Chaos Monkey. At its heart, really simple thing. All it does is picture the analogy of you having a server rack. You put a monkey in a room with that server rack, it's going to start pulling those cables out. It's going to randomly start taking down instances. You won't know what instances, you don't know when it will happen, but you should, and that's all there really is to it. There is 2 versions of this. So the original version they were working on for a while, and they really bulked it out. So you can do like CPU throttling, you can throttle your user traffic, things like that. The issue there was that it was very much tightly coupled with AWS. They've since released a version 2, which just goes back to the very basics of that monkey pulling out those cables. It just tears down random instances at random times, but it does work on Google and Azure as far as I know. But ultimately, if something goes down, we'll have our Kubernetes, we'll have our auto-scaling groups. We know it's going to pick up. We trust Amazon to handle this for us. Amazon is just this black box that we unpredictably just give everything to and expect everything to just always work. Amazon reiterate their 4 nines of reliability. Like S3 has like 11 nines, but even they go wrong sometimes. So what do you do in that scenario? So we story time. Imagine 2012, you're sitting, feet up, it's Christmas Eve, sipping away eggnog. Your system handles everything fine. You've tested it maybe with Chaos Monkey. It does automatically pick those things up. You're with AWS, so you have those 4 nines of reliability across everything. But who here uses ELB, Elastic Load Balancer? What happens when that goes down? Ultimately, you might not have a single point of failure in your system, but Amazon kind of do. This wasn't. This happened. So it was 2009. The ELB for the entire EU West region went down. Wasn't availability zone. That was in region. And ultimately, this happened to Netflix. They went down for I think 20 hours. There's nothing you can do. You can't sort of anticipate something like that happening. You trust Amazon to handle these things for you. So ultimately, it got back on, and obviously since then, Amazon and Netflix have both, tested for these things. They've adapted, so something like this can't happen again, right? Then we fast forward to 2015. Happens again. That was, sorry, the original tweets. So yeah, whatever. So yeah, Netflix, after that event, basically started to bulk up their Chaos Monkey. So they released Chaos Gorilla and Chaos Kong. Chaos Gorilla takes down availability regions, and Chaos Kong takes down entire regions or zones. Is that right? So then, whenever it did happen again in 2015, this time it wasn't just the ELB, it was 20 services they provide. Now, Amazon do offer a lot of services, but I think in 2015 they maybe had like 35, so 20 of those going down. That's pretty serious. But in that regard, because Netflix have built these resiliency tools, they built this into their production path. Fair enough, I think they took a slight speed hit in terms of responses, but they didn't flinch. Nothing went down. They literally just moved everything across to, it was Europe or something like that. So, albeit, it's easy for me to see exactly how I would implement this from the get-go. But what happens if you already have those 20,000 nodes? You're not going to come in, install a semi army, and just nuke 50% of your services to see what happens. So that pretty much what happens is you get an email that says, "See you later." So we need to think about how we actually roll this out, what strategies we need to apply. So ultimately, our goal is, we don't want to disrupt anything. You shouldn't be rolling this out if you already suspect that your system will not handle this. Chaos engineering is about affirming your assumptions. You should already assume your system can handle these things. Ultimately, it is a big thing. So there's 4 sort of steps you can take. First is define what your stable state is. What your average traffic looks like. How many, is there an average dropout at X? What's your CPU average handle? Again, you hypothesize that yes, this is what I assume everything's going to be like. Even if I, apply the experiment to it, it's still going to look like this. Then you start thinking, right, okay, how can I start messing with this system? What can I start poking? What happens if this service comes down? Do these other services also go down, or do they fall back to something else? And ultimately, we're not trying to win the battle. We're trying to lose. We want to be wrong. We want to find those weaknesses on our system. So we try to disprove it. So start small. As I say, you're not going to nuke half your system. If you have 20 services, try it on one of those services. Try it on one user scenario that, even if it happens, it's going to be fine. Keep it simple. So, you could spend a month devising all these chaos scenarios. Only that's a waste of time. You just want to find the most probable one that's going to impact your system. The most obvious things. Start with them, and then you can get granular. Big thing is log everything. Yes, you'll have metrics already being logged out, but in 3 months' time, those metrics won't be the same metrics you use today. In 6 months' time, you'll be recording twice as many things. You need that historical data to be like, oh, we should have been tracking this, but we've got this data now. We can see the trends it's supposed to be. And ultimately, alert. This is your metric as a site reliability engineer. This is what you're ultimately tracking. If something goes down, do you get an alert for it? Are you on pager duty? Do you get the wee text message at 2 o'clock in the morning? If you don't, that's an issue. That's something you need to add in and work on. But ultimately, this all needs to happen in production. You can roll out to an isolated cluster at the start to make sure things do actually recover, then roll out to maybe a staging instance where more services are interacting with each other. But it's going back to that user testing. You cannot possibly fathom the way your app or your service will interact in the wild. What happens if Frank hits refresh on a page 50,000 times in a minute? Does your site just crap itself because it's got all these requests, or does it just sort of auto scale up? Whenever you're first doing this, a good idea is to set up a war room. So this goes back to if you have these 20 services and you're going to test on maybe 2 or 3 of these services at the same time, you want the people in charge of those services in a room. This isn't just pure chaos, this is managed chaos. We know when this thing's going to run. We know what services it's going to attack. So we know the people who are going to have to respond to this thing. Get them in a room for an hour. And basically, if something goes down, the people in charge of it will just probably shout at each other for half an hour. The other people can then log everything that's actually happening. And then once the dust settles, once you've done your user testing and things have hopefully went wrong, you need to then carry out the post-mortem. You need to actually sit down and think, why did this happen? And how we address resolving this so it never happens again. The main thing though, obviously from a ops side, chaos engineering, it sounds nice. We want to make sure our site is resilient, reliable, but we're not the only people in the company who this is going to affect. It is going to, if I'm a developer and I'm working on my service and I think it's all bells and whistles, and someone comes around to me and like, well, we're going to start messing about with it. Like, no, that's my wee baby. You don't touch that. So at the start, it is very much an opt-in process. You have to justify why you're doing this. All my justification is simple. You don't want this thing going down. It's probably those teams that are going to have to get this phone call at 2 o'clock in the morning. And then in terms of managers, ultimately it comes down to this. Would you rather your engineers be battling these fires at 2 o'clock on a Saturday morning when they're groggy, just woken up, or do you want them doing this whenever it's Thursday, 2 o'clock, and they're expecting it to happen? And that's me. And so just some resources. So that's the original Simian Armory, which has the sort of version 1 Chaos Monkey. And then there wasn't like a Docker thing to play about with to actually use the Simian Armory. You have to use another autoscaling group. So I've set up just a wee playground where you can get set up with the full Simian Armory in like 5 minutes if you want to have play about it yourself. And that's me.
Okay, thanks very much, Mark. Any questions for Mark from the floor?
Yep.
Quick one. Chaos Monkey, Do you launch it with parameters? You say run for the next 10 minutes, and after 10 minutes, if something's gone crazy or something.
Yeah. So yeah, it's fully managed. You can say that you want to run it for. I think it refreshes every hour by default, so it'll run a different scenario every hour. But you can set that to every 5 minutes and for a particular window. So between, as I was saying, a Thursday between 2 and 3 o'clock, you want this run, and then you can just instantly kill it. Or you can. The dream would be that you ultimately deploy this up into your staging thing. It just constantly lives there. Every Thursday at 2 o'clock, this thing's going to attack, so you track it then.
And are you mainly running it running in staging, or are you just shucking it against production because production's a real?
Yeah, production. Yeah, there's no real point in throwing it against staging because how many users are going to be using it. It's your own devs who they're not the users testing it weirdly. It's all about testing it in production.
Thank you.
Yep.
Can you have it sort of output events to your monitoring system to make correlation easier?
Yeah. Oh yeah. So everything I think they've native API that goes to Datadog, but you can set it up. It's the open APIs that you can just point all the logs to whatever you want. It also natively, obviously, logs to standard out. Yep.
And is it the sort of thing that you just run at 2 o'clock on a Thursday, or can you not just leave it running?
Well, that's it. Ideally, you would, if you want to run it all the time, there's a chance that you really want to run it maximum, 9 to 4 o'clock, because you don't want a call at 2 o'clock in the morning just because the chaos monkey pulled out something. Your system would have been fine if this thing hadn't been running. You would have got a peaceful night's sleep if this thing hadn't been running. So you want to manage it in those time blocks realistically.
Yep. How does the business typically respond to you saying, here, I've got this really great, I want to production infrastructure? Yeah.
So, that's where I have, a bias. I'm starting a brand new product. This isn't an existing thing. So they just see it as extra reliability, extra confidence in this platform. So they're all for it. Obviously, if you're going into an existing platform and running this, they'll be a lot more wary. They'll wonder why, for one, why is it only coming in now? If we start using this, will it break all the things? Yep.
Have you come across anything that captures the common problems people have that Chaos Monkey uncovers? So you can just have a playbook of stuff to avoid?
Yeah. Well, even that sort of goes against the whole chaos principle. They would be things you test against. That's knowledge already collected. But I haven't seen any sort of common issues. Any sort of blogs or sites that just list everything. Yeah. Oh.
Have you just run it on? You just used it on the one new system that you're developing?
Yeah.
So do you think that you would capture completely different problems where you'd be working it, applying the same tools to?
Yeah. Well, I would hope so. Ultimately, this tool is all about finding those wee bugs. I have a very clean system where I'm running this in. It's a very clean environment. I know it's still very small. If I applied this to, Netflix have hundreds of services. If I applied it to something like that, I think as of 3 months ago, they had 193 open issues that the Simon Armory detected, and they get a new one every single day. This is an ongoing learning experience. You'll never stop finding issues. There'll always be weird bugs.
And is it sort of able to run where you've got a hybrid cloud sort of architecture? Is it capable of operating across multiple clouds simultaneously?
No, it is. Don't say I haven't really tested it, but I think it's quite tightly coupled to a particular sort of instance. Yep.
Does Similarm has ability to detect that, oh, I bring this service down, I'm
Yep.
just stopping and not touching it anymore, or
Yeah.
it throws?
No. Oh yeah. 100%. It's not going to beat a dead horse.
Yeah.
If something's down, it will realize it's down. It will log that, and it expects you to then say everything's fine again.
Okay.
Go away. Keep testing. I don't know if it's by default, but there's certainly APIs for that. Yep.
One final question. Is it this concept that you want to help self-heal so it stops you getting pager duties when?
Exactly. Yeah. Like the dream of this is that we never get another text message at 2:00 in the morning. You want to, if we can eliminate, 50 user scenarios during working hours, it means those 50 don't come up out of hours.
Yeah.
Yeah.
Great. Any time for maybe one more question from the floor? No? I have one quick one, which might be really stupid. When you say it unplugs
Yep.
things, in AWS land, are we talking about it brings down EC2 instances, or can you tell it to bring down services within
So it'll bring down instances. It won't actually affect the services. You can, with version 1, you can set up that so it does simulate, your database can connect or whatever. But version 2 is just all about sort of taking down those instances.